graph, it seems to me like you guys, raise your hand if everybody was able to get all of these coordinates. We're okay on the coordinates? So we're plugging them in and spitting out a coordinate, and then we're putting the coordinate in a t-table, and then we're going to plot the points. So if I were going to zoom in on this a little bit to plot the points, just to review, if I want to plot -2, +4, I always start at the origin and go down left 2 and then up 4, and so I should get a point right there. And then the next one, -1, +6 gives me a point right there. And then 0, +8 gives me a point right there. And 110 isn't actually on this graph, but it would be about right here. In other words, the axis doesn't go up that high, but that's where it would be. So you were right in saying that it's a line pattern. Those are connected by a line. And that's what we're going to be working on this chapter, is graphing points and focusing mostly on lines. And so we begin with t-tables. This is a t-table right here because it looks like the letter T. But in your book, you're going to see them sideways also. So you might see the same thing in your book, like this, and you would have the same exact information stored a little differently. So on and so forth. So be flexible and be able to read both horizontal and t-tables. Okay? The other thing is we're going to talk about today what a solution is. And we did that a couple, 4 or 5 weeks ago in one of our tests. We talked about solutions. The solutions were numbers, coordinates that made an equation true. So, for example, -3, 2, that is a solution. That's one of the words that comes up in your homework. It's a solution to this equation. If I change this to an equation and write y equals 2x plus 8, because when I put in -3 for x, remember this earlier this year I put a question mark here and I said, does that equal -3? And then you would work out this side. I'm sorry, but does that equal -2? +2. You would take the y coordinate here and plug the x coordinate into here, and then you would see if you had a true statement. And in this case, since we worked to make this in the beginning work out, we know that that's a solution. So I want to show you what that looks like on the graph.
So if we had two variables, one in the solution and one in the problem, you could get the answer and it would.
Yes. If you have two variables, which we have here, we have x and we have y. Here's the y, here's the y, here's the x. When you plug in an x value, you'll get out a y value, and one way to correctly write that is, for example, when x is -1, we know that y was 6. You can write it in coordinate form. So coordinate form is a way to store x and y without keep saying x is this, y is this. Once it's in a coordinate, it means x is -1, y is 6 by its position. And it also means we're interested in graphing when we use coordinates. Yes?
Which one do you do first?
It's always alphabetical. X comes before y, left to right. And a solution will land on this line. So, for example, if I took this a little bit further And if I said, is -2, 5 a solution to y equals 2x plus 8?
No.
You're going to say no. That's correct. It's no. Why?
That's to -4.
Because 2 -4 is, and it like
Or -2, 4.
-2, 4 is, and like what Skylar was saying, it doesn't fall on the line. So both reasons. So no, because when we plug in the -2, like what Adam's saying, we end up getting four, and that's not equal to 5. So that's how you show it algebraically. And also, what you'll be learning is graphs, equations that look like this make lines. And we'll talk a little bit more about different ways to get those graphs. But if we look at -2, 5, it's not on the line, so it's not a solution. A solution would fall on the line. Where -1, 6, that is a solution. Like we showed up here, because it lands on the line. So just to recap before we go on, we're taking material from the beginning of the year, the word solution. You guys worked with it algebraically, and now we're going to tie those solutions into a picture. And by the end of this chapter, you're going to have different ways to graph lines. Probably you'll have 3 ways to graph lines. It's not just a t-table, but today we start with t-tables because those are the most logical at first. Any questions so far? This is your kind of chapter 3 introduction. Last Friday we did a little bit of plotting points. I know I didn't go over those papers. I'm going to wait till tomorrow when I pass them back, but I was walking around and it seemed fine. You guys were very comfortable plotting points. So, continuing on, here's how your homework looks. Again, I'm recording this, so if you just want to watch and maybe that's more helpful than writing down, that's okay too. But we just kind of talked about this. Real quick recap, we won't do both of these. This is how your book will ask the questions. They won't have the graph at this point. So even though I just talked about the graph, you show algebraically. So, Will, what should I do? And we're not sure yet, so I just put a question mark. 8 is equal to, or maybe equal to 2 times 4 plus 8. And the reason I put these up is what we showed algebraically how something is not a solution, but let's just confirm that you really understand. So that's 16, right? So yes or no, class? No, not a solution. So you show a contradiction.
So when A, so it will tell you what, so it tells you it tells you what X and Y is.
Yes, so this is X and this is Y, just because of its relative position.
So they'll have that.
They give you a point, and you determine if it's a solution, and if it's not, you say, you could say, like, 4, 8 is not a solution to what?
Y equals Y.
Right, because it could be a solution to something else, but it's not a solution to what they're asking about. Okay? Skylar?
But couldn't it work using the x as a negative?
You would have to test it out. So if x was a negative, no, you would get 0. Okay. What about this one over here? You would say 4, is that equal to 2 times negative 2 plus 8? What about that? What's this?
What?
2 times negative 2. And this is 4, right? So is it a solution? Yes. Your battery is low. Oh, so it's not plugged in. Okay. Takes it out. Okay. So we would say yes. Negative 2, 4 is a solution to what?
To y equals 2x.
Right. Raise your hand if you understand. Okay. Let's see what else we got. So, now make solutions. So you guys do that yourself. Let's try that. I'm giving you the x, you give me the y. So it's the same, right? It sounds like a different problem, but it's...
Wait, no, on B you gave this.
All right. So I have 2 different ways. Part A, I'm giving you the x, you give me the y. That's easy. Part B is a little bit harder. I give you the y, you give me the x. That becomes the solving. So try those on a piece of scratch paper. And I'll... Okay. Just checking 6. We're plugging it in for x. So 3 times 6 is negative 18. 18. Negative 18 plus 2 is negative 16. So that tells us what y is. So the ordered pair is 6, negative 16. Questions on that? I heard different answers.
I just have the problem written down.
Okay. Well, that would result in a different answer. So that's okay. Yes. What'd you do on the next one, Natalie?
I like what we've been doing.
Yeah, it's just what we've been doing.
But what's the first thing tonight at 14 equals negative 3x plus 2.
Okay, do you guys see how that just ties into the old material? All this is just tying into the whole first quarter of school, right? So what's the next step that you would do, Matthew?
I did minus 2.
Right, so minus 2, subtract 2 from both sides. And then, Elena, what do you get on the left? 12. And then negative 3x here. And then, Ingrid, what do we do next?
And then you divide each side by negative 3.
Divide by negative 3, good. So we have 4 negative, thank you. And so that tells us the ordered pair is negative 4, positive 14. And that's your answer. Does that make sense? Okay, good on that? So let's see, one more thing. I think, actually, tonight, that's pretty much it. Let me double check, but I think that's everything for tonight. So let's look at page, why don't you guys take out your book and look at page 124 before we leave, and I'll do the same. Right, so if they ask you to graph something like this right here.
And so we put like a number next to it?
Yeah, so you would just make a t-table.
So like number 12 and number 13.
Right, but what I would do every time I make a t-table, in the warm-up, I pick the points for you. You have to pick the points, but pick easy, smart points. So easy, smart points would be things like, let me make that smaller. You know, that, like 0 is easy. Pick a couple negatives and a couple positives and see which ones are the easiest to plot and plot 3 points. So usually what I do is I make it symmetrical in my table, so I put a 0 in the middle. And then I just do like -1 above and +1 below. Now, whenever you make a t-table, you can use mental math. I always had this rule in 6th grade, so some of you might remember that. But I'm going to plug -1 in here. So -3 times -1 gives me a +3. If you're not sure, absolutely work it out. So y equals -3 times -1, take away 5. So this is 3 take away 5. And what is 3 take away 5? No. Negative. It's +3 take away 5. -2, right? So in my t-table, I have a -2. Now go to 0 and put 0 in here. Well, what's 3 times 0?
0.
Take away 5? -5. Okay, now go to 1. What happens when you put a 1 here? -8, right? If you pick evenly spaced numbers here, you guys, like these are all 1 apart, you're going to get evenly spaced, you'll see a pattern. This is going up by how much?
3.
3, or down by 3.
Oh, yeah. Will we do a t-table for each one?
You do a t-table for each one.
Okay.
So the work you're going to show is a t-table. You can show this, but you can do mental math. It's good practice to do mental math here.
So we only have to do 0, -1, and 1.
Well, you have to pick smart points. Those are easy points. Sometimes you might want to pick like -2, 0, and +2. Pick 3 points. And then you're going to plot them. So the reason I don't want to say always that, because you want to make sure your points land on your graph a little bit. So maybe those aren't always going to work, but a lot of times they work. So you have to try them out. And look at those examples and see what they do. So I'm plugging -1, -2. That's my first coordinate. So you're going to plot it. You're going to label it. And then you're going to do the next one, 0, -5. So here's the reason I may go back and say, wait a minute, those points aren't working great for me. 0, -5 is not bad. But the next one's not great. I'd rather get a point that's higher up. So I go back to my t-table and say, I'm going to go to -2. Because I want a point that's higher up so I don't have to make my graph go really low. When I plug in -2 here, y equals -3 times -2, what do I get? What's this? 6. Take away 5 is 1. So that point ends up being easier for me to plot.
And so we would make a graph also?
That's what you have to do, right? So it's a graph. So let's see if I plotted that right. 1, hold on, I need to zoom out. It's hard to see. Something looks funny there. Did I count wrong? 3, 4, 5. This point's in the wrong spot. You see, I counted wrong there. How could I tell, guys, that I counted wrong?
Because it was like unevenly spaced.
Yeah, it was unevenly spaced. And then you take a line, and a straight edge, and you draw your line through those points. So do you understand, for the graph, you need to label the points, include the t-table, and then draw the line.
Or just 3 points, right?
3 points is plenty.
3 points per problem.
Okay. 3 points for each graph. All right? I'll save that and put it in the playlist tonight.